Alright guys. I need everyone quiet please. Okay, everyone quiet. So, what we're doing today is we're basically looking at an infinite geometric series or power series. Everyone, when n is 0, do we agree that we plug in n is 0, you get 1. Then you plug in 1 and you get x, then you plug in 2, you get x squared, and so on. Cool. So you get 1, then x squared. Great. We're setting the problem up to converge. So basically, the thing you're timesing by each time is your r. R is therefore x. And if you take the absolute value of that, you're setting it less than 1 to set it up to converge. Everyone good? Now, if I asked you to find the sum of a geometric series, infinite geometric series, it's a1 over 1 minus r. Everyone, what is a1 here? 1. What is r? Great. So this thing equals a1 over 1 minus r. Does everyone see that? All right. So infinite geometric sum basically, if you have a series where it's x to the n, then according to a1 over 1 minus r, you would get 1 over 1 minus x. This is going to be the sum, this is the series, and we're going to go in both directions. We're going to be given a function, and we're going to put it back in series notation in this lesson. So it's really strange that a sum equals a rational function and vice versa. A rational function can be written as an infinite sum. It's bizarre. So that's what we're going to be doing, is we're going to look for things in this form. It specifically has to be 1 over 1 minus something, or 1 over 1 minus x, where this, whatever's in here, goes right there. One more time, whatever, bless you, is right here is going to go right there as x to the n. So that leads us into our first example. The first example, bless you, is 1 over 1 plus 9x squared. So to get this in the right form, you're going to rewrite it as 1 over 1 minus, what would go inside that parentheses? Negative, great, 9x squared. Now this function is of the right form. It's specifically 1 over 1 minus something. According to this little pattern here, 1 over 1 minus something is the sigma of that something to the n. So here we're going to rewrite this as sigma. And then it's negative 9x squared to the n. Multiple choice, the answer will not look like this, most likely. So we're going to do a little bit of manipulating. We're going to pull the negative 1 to the n as an alternate series in front. That would leave you with 9x squared quantity to the nth power. And then very last thing, does everyone see the 9x squared could both be something squared?
Yeah.
Do we all agree 3x quantity squared makes 9x squared? And you would pull the 2 out, but you already have an n, so you say 2n. And this is how the answer would probably be on a multiple choice test. Okay. TAs, are you guys okay to grade homework, or did you already grade the blue? Okay, thank you so much. Oh, do you want to put up the sign? Great. It is. Okay, never mind. It's fine. Okay, so we found a power series representation for the function, but now it wants us to find the interval of convergence. So, your interval of convergence, you can do root or ratio test. I want to show you guys root test. So for the root test, go ahead and write the limit as n goes to infinity, bless you. Actually, guys, sorry, backtrack. Do you want some whiteout? So you can plug this one in, but look up here how convenient this one would be.
Yeah.
Let's use that one. So the nth root and the n undo each other. And all you have left is the limit of negative 9x squared inside absolute value. Do we all agree that absolute value of negative 9x squared has no n's in it? So it's treated like a constant. You can move it to the front, or the limit of a constant is just that constant. I'm going to pull the 9 out and set this, because we want it to converge, so we set it what? 3. We set it less than 1. Next, you're going to divide out the 9. And you end up getting that x is less than 1/3. Ooh, absolute value of x is less than 1/3. So your interval is going from negative 1/3 to positive 1/3. And last, you get to check your endpoints. Woo! Again, you can take your endpoints and plug them in. To this series, you could use this format, or this one's going to be really convenient right here, because when we plug in negative 1/3 for x, remember you're always plugging in for x. So negative 1/3 squared makes what?
9.
1/9. Good. The 9's cancel, and what's left? Negative 1. Good. So we're plugging in 0, then 1, then 2. This thing oscillates from what to what? 1 to negative 1. And so according to the test for divergence, the limit of something oscillating from 1 to negative 1, does it exist or not?
No.
Nope. So therefore divergent by which test? Good. And again, I'm not going to show the work. These problems are already lengthy enough. So if you had to show work, you guys know you would take the limit of just this, right? Okay, and say, does not exist. Okay, cool. And when you use the other endpoint, again, you're taking 1/3 and you're plugging it in. Right here, 1/3 squared is still 1/9. The 9's cancel, you still get -1. So same results. And again, by the test for divergence. So therefore, your interval of convergence is -1/3 to +1/3, both open parentheses. Alright, this next problem, if you'll notice, you have something on top. Oh, we have a couple of variations. So this was a nice intro problem because it had already, bless you, 1/1 and something. Again, 1/1. It was easy to go minus, minus, and then you got it right in the form of 1/1 minus something. And then you can drop it straight into the sigma notation. This one is definitely not like that. So pull the numerator to the front, and then now you have the 1 on top. In the denominator, if you have x and a number, first I need you guys to flip them around so that it's the number and then the x term. The next step you're going to do is you're going to factor the 2 out because it has to be 1 minus something. So if you factor a 2 out, it's now going to be a 1. And if you factor a 2 out of x, what algebraic expression is left? Nice. And we're basically there. Okay. So we're going to write x cubed over 2 and then sigma. This part of the problem is in the right form, 1/1 minus something. And so the way you put it straight into sigma is you just go sigma and it's the something to the n. Now we just need to clean it up. So we're going to make it alternating by pulling the -1 and writing it to the nth power. Does everyone see that when you pull the negative out, over here you would have x to the n and 2 to the n? I need to make sure everyone understands that these are equivalent. Again, the negative to the n got pulled out. And then you have x to the n, 2 to the n. Is everyone okay? Last step, we're going to move all of this back in. And in order to move it back in, do you add or multiply those exponents? Any guesses?
Odd.
Add. So what would the 2 have as an exponent? Nice. Okay, so that would be your answer for that. Make sure that you guys study this. Getting to here, a very, very straightforward test problem. Multiple choice or written, but you need to get it all the way to here to be in power series form. Power series form. So this is power series form. All right, now the interval of convergence. absolute value of negative 1 to the n, that just takes care of that. Remember, this is the same as to the 1/n power, correct? This right here. So remember, it's all of this to the 1/n power, so you distribute the 1/n to everything. So, think of it as 1/n, and you're distributing that to everything. That makes this new exponent become 1 plus what? Okay. And then in the denominator, 1 plus 1/n. N gets larger and larger, 3/n and 1/n, what numbers do they go to? Yep. So that goes to 0, that goes to 0. So you're left with the absolute value of x over 2. And everyone, we set this what? Less than 1. Perfect. Alright, we check endpoints. Okay, this first endpoint. Remember, you plug -2 in for the x. We're going to split this to -2 to the n and -2 to the 3. And then this right here is -1 times 2, which can be written as -1 to the n, 2 to the n. That's helpful because what cancels on top and bottom? Also, this and this. This is getting crazy. -1 to the n times -1 to the n makes -1 to the 2n. Everyone, -1 to the 2n is positive. So, all that's left is this over here. That's it. What number does that reduce down to? Yep. Just -4. According to the test for divergence, if you guys take the limit of -4, you just get -4, which doesn't equal 0. Therefore, the series does what? Diverges by the test for divergence. Okay, similarly, the 2 to the n's cancel here. And you're just left with what number? Four. Okay, by the alternating series test, this would be your B sub n, correct? Does that decrease? No, so alternating series test cannot be applied. So when the alternating series test doesn't work, you automatically use which test?
Test for divergence.
Test for divergence. Everyone, the limit of this will oscillate from what to what? 4 to -4. Do we all agree that limit does not exist? Yes, therefore divergent also by the same reason.
Oh, okay.
Oscillating? Oh, sorry. Oscillating? Interval of convergence is -2 to 2, not inclusive. Okay. Question.
So, if it doesn't ask for the radius, it's not going to put the radius.
Correct, it's not asking for the radius. Same thing on multiple choice. Sometimes they'll only ask for the radius of convergence and they don't want the interval. So just pay attention to what they're asking for. All right. Whoa, we're halfway there. All right, guys. Partial fraction decomp.
Oh no, I hate
They have those like 10 shells.
Yes, you made a blunder. You are a blunder. I made a blunder. I'm a blunder from I'm Bendy from Bendy and the Intuition. You ever play that game? Oh, that's like Cuphead, except I don't actually know how the game plays. Oh, Bendy and the Kiss game? Except it's a horror.
Except it's been 8 hours by next grade by seriously. I'm not wrong. Yeah. You play that?
No, I play Stick Fight Brigade.
All right. In order to eliminate, you need opposite A's or opposite B's. What do you guys want to times the bottom equation by?
3.
Great. When you times by 3, make sure you distribute and then add down. All right, so A is 1 and B equals 2. Once you identify those, you're going to put them back into the function. A is 1, B is 2. And now, we need to get these of the right form. So 1 over, and we're going to flip these around. Also, I'm going to factor out a negative. So when you factor a negative out, it'd be minus parentheses 1 minus 3x. So covering up this negative, you have it of the right form. 1 over 1 minus 3x. the second one, pull the 2 to the front, and you have 1 over 1 minus negative x. We now have a double series problem. Yay! I'm not going to give you guys a double series problem on your test. There is one on your homework, but there will not be one of these on the test. But I do want to leave it in your notebook, in your notes, so that you have it for reference for your future life. Yay!
You did miss your.
Calc is constitutional.
Okay, next. We can pull the summation, the sigma to the front.
And win. I'm gonna laugh when you lose.
When you what?
Yeah, I'll laugh when you lose.
Confidence is shutting down up to the second.
And then I'm gonna flip these around, so I'm gonna move this guy over here. Does everyone see what I just did with this negative 1 to the end, x to the end?
Yes. Yeah.
I'm gonna put.
Oh my god. Got a quitter.
And finally, oh my gosh. Do you,
I'm going to say.
I know. Do you guys notice they both have x to the end in them?
I see that one, but I don't see it.
Oh yeah, you just pull it out.
Pull it to the back. Okay. So that would be in college, if you have a problem like this, how it would be more written for a multiple choice answer. Now, for interval of convergence. What was that? Interval of convergence, root test. You're going to look at the individual roots. So we can go all the way back up to here and use each of these and do individual root tests.
How are you already at the bottom of your page? Oh my god.
I'm a PC.
I'm not very happy.
Well, you can do this
No,
and
you
pencil
can't.
and go back.
You wonder if
I'm just gonna draw an arrow. That happens a lot.
Make another.
I'm a 400.
All right, and group, power of n, they undo each other. And absolute value, so all you have left is 3 absolute value of x. Then you set that what, everyone? I know. I didn't even realize that when I said that. Over here, the nth root n. Oh, I did it again. Sorry, this is incorrect. Oh wait, I haven't even
Oh, I think first you wrote.
Okay, right here, does everyone see that nth root cancels with that n? But you still have a 2. So the 2 would be to the 1 over n power like this. So as n gets larger, this fraction goes to what number? Great, 2 to the 0 is 1. So you end up getting
I know, but it messes up the system.
n set at less than 1. Now, here's the deal. I need everyone to stop talking really fast. This is an and problem you have when you have a sum of two series and you have two different intervals. You take their intersection. One more time, when you have a original sum of two series. So do we need to write that? Probably. So sum of two series. Take their intersection. Okay, so what I mean is, on the left, you're looking at the interval from negative 1/3 to positive 1/3. But on the right, you're going from negative 1 to positive 1. So think about this with me. If this potentially only is convergent from negative 1/3 to positive 1/3, but this guy goes from negative 1 to 1, we're looking overall for an interval of convergence. Again, this one only potentially converges in this window. This one potentially converges here. But if you're looking overall, would you guys think to take the smaller or the larger?
The larger.
The smaller includes the larger.
Huh?
No,
the larger includes the smaller.
So hold on, let me think. Let's time out. Overall, you want to know, where does this thing converge, right? You have one side of it only converges here, and the other side of it converges a little bit further out. But ultimately, you need to know, where does the whole thing converge? So it's going to be their intersection. It's going to be the smaller of the two. Does that kind of make sense? Because they both converge from negative 1/3 to positive 1/3, right? But this one converges outside of that, so you have to use the smaller of the two. So you're only going to consider.
I said smaller.
Yeah, you were wrong.
Well, it
I
contains-
mean, technically,
it
Jill,
contains
like,
the
that's not a very
intersection.
good
Yeah.
way
Yeah,
to describe it.
Thank you, Sarah.
Okay, so when you do that, you check endpoints, and you check the endpoints with the smaller series. Yeah, what game are they playing over there?
I didn't have a complaining class.
Okay.
Oh my god.
It's just
It's
We literally could just do whatever we want.
Yo,
It's
so
not like
listen
we
to
take notes. It's like, we literally have like 40 minutes every day.
This has erased all my memories of fun.
Oh my god.
This is very dramatic.
Who cares?
This is all being recorded. It's cool.
Oh my gosh.
The ones
That is
that are all
being
better.
Oh.
I'm just gonna cry myself to sleep and reevaluate my choice as a career.
Start teaching only remedial math.
Oh, isn't that a huge problem? It's a calc problem. That
Remediation
it's so
is
complex.
called.
I can't believe we would do this.
That's no, I think we have a problem with
What's that? Negative.
It's okay. Last walk I made a mistake and Patch started booing me. I was like, go find a better Calc teacher.
Oh, I didn't say I don't like Yo, I said I don't like calc. I like Mrs. Yo.
We're good, we're
Yeah.
good, we're good, we're good. Okay guys, as you plug in 0, 1, 2, 3, 4, this will alternate, but then if you times by negative, it still is alternating from 1 to negative 1 to 1 to negative 1, yes.
How did you decide which equation you were going to plug?
Yeah, so I used the 1/3 and I went back up and I was like, where did the 1/3 get generated from? And it came from this series. So you want to check the series the 1/3 came from.
Where do you get these?
Stop that up right now. That's creative. That's creative.
Yes.
Negative.
Say it again. So as you plug in 0, 1, 2, 3, 4, this is going to oscillate from 1 to -1, 1 to -1. But once you take those numbers and times by another negative, then they change to -1 to +1. You know, still oscillating.
So you can't just cancel them and put like 1 to the end, is that what
No, because if you think about order of operations, you would do exponents first, then multiply. All right, so diverges by the test for divergence. Next, go ahead and plug in 1/3.
Right?
Yes.
So now these guys cancel. And you get -1 to the n. As we plug in 0, excuse me, 0, 1, 2, 3, 4, you just get 1, but it's negative. So guys, if you always have a -1, the limit of -1 is -1, doesn't equal 0, so it does what?
Diverge.
Diverge by the test for divergence.
Told you, Milan.
So your interval of convergence is -1/3 to +1/3, not inclusive. Whew.
Told you, Milan.
Yes.
Good.